Hi there, physicists. We are going to learn today how to add vectors together using a method called tip-to-tail vector addition. So here on the screen, you can see two vectors. The first on the right here is vector M in purple, and on the left is vector L in blue. And we can tell that these are vectors because vectors are numbers with direction and magnitude. So direction is indicated by the direction that the vector or arrow is pointing, and magnitude is indicated by the length of the arrow. So in this case, for M, for example, the vector is pointing, that way, and its length is, pretty long, whereas L is pointing the other way, and its length is ever so shorter. So if we were just to compare the sheer length of vectors M and L and not worry about which way they are pointing, we would be comparing their magnitude. Magnitude being another word for like value or quantity, and the length of the arrow indicates its magnitude. So before we start adding vectors together, let's look at how to measure them. So with direction and magnitude, we have two different measuring tools that we have to use. The first you're probably the most comfortable with, and that is a ruler. Picture on the bottom here. We measure magnitude with the ruler because we find the length of the arrow. Now, in order to do that, we are going to use the metric side of the ruler. Usually you have inches and centimeters on a standard ruler. And in this case, we're going to use the centimeter side. And centimeter is a metric measurement. Each of these numbers here indicates 1 centimeter. And you might be familiar with the metric system. Like a meter stick is 1 meter, very close to a yard. And a centimeter, if I spell it out, has that prefix cent. There's 100 cents in a dollar. There's 100 years in a century. A centimeter is 1/100th of a meter. So on a meter stick, there are 100 centimeters. Now, if you look very closely at your ruler, you will notice that there are these tiny dashes. And if you count them carefully, there are 10 of these itty bitty dashes making up 1 centimeter. Each of those tiny little dashes is a millimeter. Now a millimeter is 1/1000th of a meter, or knowing that we have 10 millimeters in a centimeter, we could say that it is 1/10 of a centimeter. Sorry, that looks like 20th. I'll just erase it. Here we go. 1/10 of a centimeter. So in other words, each of these hashes in between the centimeter numbers indicates 0.1 of a centimeter, 1/10. So if I had a arrow, let me draw an arrow real quick, and I wanted to find the length of it, I would hold my rulers in such a way that the beginning of the arrow would start at 0, and it would extend to, wherever I wanted to measure. This ruler, unfortunately, does not rotate, so I can't show you guys how I would hold my ruler over this arrow. So we'll use this red arrow as an example. So this red arrow here, again, the starting point of my arrow is lined up with 0. That's something you have to do very carefully. And now I can see where the tip of the arrow, the very pointed end, lines up. This arrow extends all the way past 4, but doesn't quite reach 5. So I know that that is going to be 4 point something centimeters. And if I count very carefully, knowing that this halfway mark is 0.5, I can see that we are about at 4.8 centimeters here. So in order to measure vectors, their magnitude, you'll just use a ruler and see where on the centimeters side it lines up. So you might wonder now, okay, how do we use the direction? Because we could say, you know, north, south, east, west, but to be more scientific, we are going to use degrees. So we're going to measure how much this arrow is away from the positive x-axis. Now what I mean by that is on a, you know, imaginary coordinate plane like we have here, we have an x-axis and a y-axis. And our positive x-axis is the one going to the right. We know this from math class. You know, this is positive x and this way is negative, negative x. All the numbers to the left of the origin, which is, of course, the very center of the graph, where it's 0, 0. All the numbers to the right are positive, all the numbers to the left are negative. And you do the same thing with the y. Of course, the positive y is up above, and all the numbers going down are negative y values. But we're just worried about the positive x-axis. So we're asking if we go counterclockwise. So thinking about how a clock goes, you know, you have 12, 1, 2, 3. That way is clockwise. We want to see counterclockwise, so opposite the direction that a hand goes, clock hand goes. How far, how many degrees is this arrow from the x-axis? So we're going to start measuring on the x-axis. That's 0 degrees if it's sitting on the x-axis. And then we'll measure, like starting at 0 and going all the way around, how far do we have to rotate to reach our vector. And to determine that, we use the measurement, again, degrees, which is determined by a protractor. You guys might know that a flat line going from let's say 0 degrees on the x-axis all the way, let's use green, all the way over here, a flat line like this, you might be familiar that that is 180 degrees. And you can see that that is the shape of my protractor. I start at 0 and I end up at 180. Or you might also notice that there's another set of numbers going on the inside that count the other way from 0 to 180. It just depends on how you hold your protractor, on which numbers you want to use, the inside or the outside. So, another thing about the protractor is that you'll notice that both inside and outside count in intervals of 10. And just like our metric side of our ruler, there are 10 little hash marks in between the bigger numbers. So in this example, we have 40 and 50, and then each little line is going to represent one more degree. So halfway is 45, with that first little hash mark being 41 degrees, so on and so forth. And degrees are just that little circle that you put above the number. You might also recall that an entire circle, in order to make it from 0 all the way around back to where we started, is 360 degrees. The protractor obviously doesn't make it that far, so we'll have to get a little bit creative in our way of measuring if we end up with arrows that point in this bottom half of the graph. So let's measure the direction of vector M as an example. This protractor is nice. It has a little section where it pretty clearly shows me how to line up my protractor. So I'm going to drag it on over so that this part here is going to line up with my X and Y axis. So let's go ahead and move it. Notice that I am very carefully getting this vertical line to line up with the y-axis, and I'm trying my best so that the 0 and 180 are lined up with the x-axis, but it looks like it's not going to play too well with me. That's the limits with technology. So I can see that, let's see, I'm going to start in reference to my positive x-axis, so I want my flat lines to the right to be 0, which means on this ruler I'm going to be using the inside numbers because I don't want to start measuring at 180. And we're going to see how far we go from 0 to my vector. Now you might notice that I can pretty clearly tell that I'm somewhere between 50 and 60 degrees. However, it's hard for me to tell exactly how much. So what I'm going to have to do is I'm going to have to take off this protractor, and I'm going to have to draw my vector a little longer. So I'll use a different color because I don't want to change the magnitude of my vector. I just want to make it easier for me to see. Whoops, that was not good. Easier for me to see where my line extends off to. So I am drawing a line that is the same angle as my vector, just so it's long enough for me to, oh, come on, you. There you are. Just so it's long enough for me to see where it intersects with those little degree marks. So I can see that it goes all the way out. It's just under that 60 line. So right here, that made it really hard to see. Let me erase that. That line just barely missed that 60 line looking at those little tiny hashes. So that is 59 degrees. Okay. So that's how we use a ruler and a protractor to measure a vector's direction and magnitude. Next video, we will take those two vectors, L and M, and add them together.